Welcome back to Smith Coding and Design. This is tutorial number 4, and today we should finish the part. We're going to go through our drilling operations and then get into thread milling. So to begin, we're going to go ahead and select drilling, and then I'm going to go to my tool library, to my Tormach, and I am going to select a spot drill. So I'm going to use a 1/4 140-degree spot drill, and that matches the angle of the carbide drill that I'm going to use. So what I'm going to do now is go into the geometry. I'm going to select one of the holes, and then I'm going to select the same diameter. That way Fusion goes ahead and selects all of the tools for us. It's nice and easy. We don't have to click all of them, although we could if we preferred. The next thing I'm going to do is go into the geometry tab, and this is bad. So you notice how Fusion defaults to hole bottom, so we don't want that. So let me go ahead and click OK and show you guys what would happen. So if I simulate this, and if we left that selected at hole bottom, I'm just going to go ahead and simulate here. You'll notice that we try to run the spotting drill all the way through our part, which would essentially crash our machine and probably break our end mill. So what I'm going to do is right click and edit, and what we want to do is we want to go back to our heights, and for our spotting drill we want to choose hole top, and then we want to go down 40 thousandths, and that's going to leave us with a nice chamfer around the outside after we do our thread milling. And then we're of course doing a drilling cycle with a wrap it out. So now we'll click OK, and now we'll go ahead and do the simulation, and you'll see here that we do not run our spotting drill all the way through our part. Perfect. So what we want to do now, just to give again the holes a nice chamfer, we want to go ahead and spot the backside. So I'm just going to right click the toolpath and again duplicate just to save ourselves some work. I'll right click and edit, and then what we need to do here is go into geometry. We'll deselect the holes, and then we will enable tool orientation. And as always, we are going to rotate our part such that it would be in the same position as on our machine. There we go. And then we're going to make sure that our axes are pointed in the proper direction. So we'll go here and we'll select the Z and X plane. So we'll start with Z, and then we'll select X. And now what we'll do is we'll just press the tip of the arrows until everything's perfect. There we go, Z up, Y forward, and X to the right for my machine. And again, we'll just go back to our heights and make sure that we have hole top selected, but we forgot to select our geometry. So I'm going to click on the hole faces here, click on one, and then again we have select same diameter. So Fusion found all of the holes for us. Again, hole top for the bottom height so that we don't try to run our spotting drill all the way through our part. And we are still doing the drilling with a wrap it out, so we will select OK. All right, so that's it for our spotting operations. So now what we want to do is we want to make another drilling operation where we actually drill the holes. So I'm going to go to drill, and now I am going to select a Kinemetal Go drill that is 3.3 millimeters in diameter. Again, we're going 4,000 RPM, 15 inches a minute for the plunge rate. We'll go to our geometry. I'm going to select one hole and then use the select same diameter again. Beautiful. And this time it is okay to go to hole bottom because we are actually going to drill all the way through the part. And I'm actually going to drill the tip through the bottom, and I'm going to go an extra 50 thousandths just to make sure we do indeed go all the way through the bottom of our part. The next thing we're going to do is change our cycle. We are going to do a deep drilling with full retract, and I'm going to change the pecking depth to be 30 thousandths, and then I am going to select OK. And now we'll go ahead and right click and simulate. And as you can see, we're just going to peck our way all the way through the part. And if I stop here, orbit a little bit, you should eventually see us going the 50 thousandths out of the bottom. So let's go back and look at that. Sort of happened rather quickly. There we go. So the drill point is all the way through plus 50 thousandths. Beautiful, which is exactly what we want. So I am good with this toolpath. So what we're going to do next is go ahead and thread mill our M4 holes. So let's do that now. So I am going to select 2D thread. I'm going to go to my tool library, and I'm going to use a thread mill from Online Carbide. I have listed here under M4. I'm going to go ahead and select it. We're at 5,000 RPM, 15 inches per minute. We're now going to go ahead and select our holes. Again, I'm going to use select same diameter, so Fusion will save us some work there. We'll go into our heights tab. Now I definitely don't want to go to hole bottom. My thread mill is necked to about 300 thousandths. So I am going to go to hole top, and I'm going to go minus 0.3 or 300 thousandths. So we're going to have 300 thousandths worth of thread. All right. So now we'll go to the passes tab, and let's go ahead and change our pitch diameter offset. So I use the Saunders MachineWorks spreadsheet to figure out my pitch diameter offset, and you can actually go watch my GoPro mount tutorial series if you want to understand more about how I do that. The next thing I'm going to do is go ahead and enable multiple passes. So we're going to do 2 extra passes, and we're going to go ahead and make them 10 thousandths. And then what I like to do, or I'm going to do for these small holes, is go ahead and just repeat the passes in case there's any deflection. And it also helps clear out any chips, especially if you're using the fog buster. Okay, so I think that is fine. So now I'm going to go ahead and click OK. And now we'll just right click and simulate. And again, this will go rather quickly. It's actually going to be very hard to see since our thread mill is tiny. But I'll just use the orbit tool and the timeline here just so that you can see. All right, so that's beautiful. So that's all we're going to do is just walk through our holes and go ahead and thread them. Again, guys, use the Saunders MachineWorks spreadsheet. It really helps on getting your pitch diameter offset correctly, and my threads came out fine. All right, so that is it for the M4 holes. So now what we're going to do is go ahead and thread the G1/4 holes. All right, so again, we're going to go to 2D thread. And this time we are going to select a Datron thread mill. Again, took me a while to find a tool to make the G1/4 threads. So let's see if we can find it here. Here we go. It's the Datron, and over here is the product ID if you want to order that same thread mill from Datron. So we'll select it, and we're going 5,000 RPM, 20 inches a minute. Now I'm going to go into geometry, and I'm going to enable the tool orientation. And so what we'll thread first is the top hole here. So I'm going to orbit as it would be on my machine, and then I'm again just going to make sure that my axes line up in the correct directions. So I like just going select Z X plane, select Z, and actually that went ahead and put everything in the right direction, so I'm good with that. I'm now going to go ahead and select the hole. Again, we're not going to go all the way to the whole bottom. We're going to go 300 thousandths. So I'm going to go whole top, and then I'm going to go minus 0.3. And again, just pay attention to your thread mill. They will have a specification on how deep you can thread mill. So what I'm going to do now is go into the passes tab. And again, I'm using the Saunders Machine Works spreadsheet to get the pitch diameter offset. And I'm again going to do multiple passes. So we're going to do 2 at 20 thou. And then again, I'm going to select repeat passes. And that should be everything. So we'll go ahead and click OK. We'll go ahead and simulate. Again, we'll just use the timeline. It's a little hard to see here since the thread mills are on the small side. There we go. Beautiful. Perfect. So I am happy with that. So now what we'll do is we'll go ahead and we'll thread on the back side where the connector would go. So let's go ahead and exit the simulation. We'll go back to home view, and again, we're actually going to be using the exact same parameters since it is just another G1/4 thread. So I'm just going to go to right click and go to duplicate, and then I will go to edit and go to geometry. We will deselect the hole, and now again I'm going to just orbit the way that it would be on my machine and make sure that my axes are in the proper direction. Z and X plane. Let's go ahead and select. Select the Z, and then I'm going to select X, and I'm going to go ahead and just touch the tips of the arrows until it's pointed in the right direction. So this is wrong. Let me try choosing X again. There we go. So now it's right. Z up, Y forward, and X to the right. So now we'll go ahead and select our geometry, and then we'll go through our heights tab. Again, I'm just threading 300 thousandths. Pitch diameter offset from the spreadsheet. Multiple passes with 2 step overs, 20 thousandths, and repeating it. So that should do it for that thread mill. So we'll go ahead and click OK. And as always, we're just going to go ahead and right click and simulate. Let's see if we can see, or if we have to orbit. Again, guys, it's kind of hard to see the thread milling operations. There we go. Beautiful. So I'm happy with that. So now we have tapped or threaded all of the holes for the part, so we're good with that. So the last thing we need to do is just go ahead and do another contour and leave tabs so that we can break the part off of our fixture. So let's go ahead and do that, and it will finish the part. All right, so we're going to go to 2D contour, and again, this is our final toolpath. We get to break our part off of our fixture. So let's go ahead and get to it. So we're going to select our tool. You can select the tool from here if you don't like to go to your library each time. I just do this by habit. So I'm going to go again to tool 8 for me, which is the Gorilla Silverback 3/8 3 flute end mill. Select OK. You're going at 7,500 RPM, 30 inches per minute. That gives us right around 1.3 thou per tooth. We're going to go into geometry. I'm going to go into chain, and I'm going to go into open chain, and then bear with me, guys, while I do this. I'm going to select the contour around the bottom. There we go. Just selecting this backside edge. Perfect. Click OK, and then we'll reset our view here. And now what we want to do is enable tabs. And if you remember, we had that relief cut on the backside of 100 thousandths to give us room for our chamfering tool pass. So what I want to do is make my tab height 110 thousandths. So again, because of that 100 thousandths we already took off the back, that should leave us with a tab of 10 thousandths in thickness. Another thing that I'm going to do just to make it easier, instead of by distance, I'm just going to go by number of tabs, and I want 3 tabs. All right, so I think that's good. So what I want to do now is go into our heights tab, and instead of stock top, I want to go with model top. We'll now go into our passes tab, and what I'm going to do here is I'm going to go multiple depths, and I'm just going to do a roughing step down of 50 thousandths. Okay, so that's good. We'll go ahead and do smoothing and feed optimization. Guys, that should be everything for removing the part. So what I'll do now is I'll just go ahead and click OK. And there we go. You'll see that we have our nice tabs. That way we'll be able to break those off. What we'll do is go ahead and, of course, simulate the toolpath. And now when you break these tabs off, it will leave a nice, I wouldn't say nice, it'll leave an ugly surface with, you know, part of the tab on the back side of your part. And so let's go ahead and simulate. What I ended up doing is just, again, putting my part in a vise and taking 5 thousandths off of the back. So we're cutting a little bit of air there. That's fine. Okay. And actually, let me orbit this so that we can sort of, it's hard to see in there. We can get a better view of the tabs being created. Sorry guys, it's a little hard to see in there. So there we go. You can see the tabs. That's beautiful. All right. And so again, if we look here, when you break these off, you are going to be left with a rough surface and some part of the tabs. Now you can clip them off. Again, what I did is I just put it in a vise and then did a contour using the conversational and path pilot and just took off 5 thousandths, and that cleaned up the back side of the part for me. So anyway guys, that's it for this tutorial. I hope you enjoyed. You enjoy learning CAM with me. So stick around and we'll go through these final toolpaths and all of the thread milling on the Tormach. You'll get to see that. Thanks again for tuning in. Please like and subscribe, and I'll catch you in the next tutorial series. Alright guys, now we're just going to do our spot drilling operations. I'm using Ashara's 1/4 inch carbide spot drill. So this cycle goes rather quickly. We spot our holes, we flip over, we spot the back side. Again, we're going down 40 thousandths from the top of the hole just to give us a nice chamfer. And now we transition into the drilling. You'll have to forgive me here. I'll always use flood coolant when I do deep drilling cycles, so you'll see here that the image clarity isn't as good as it would be if I was just using the fog busters. So please bear with me in terms of the image quality. Again, I use green cut flood coolant. Alright, so now moving into the M4 thread milling. So I'm using an online carbide thread mill, 15 inches per minute. Alright, so you have to forgive me here. I forgot to turn off the flood coolant at the beginning of the toolpath, so the image will clear up a little bit here in a second. There you go. And again, I was a little wary when using the M4 thread mill my first time, because you'll notice the tip is really small, and any little mistake you would be shattering a $50 end mill. So just take that into consideration. The first time you see a small thread mill like that, you may start sweating just a little bit. You just have to bear with me here. The toolpath does take a little while, but the thread milling is kind of the highlight of the part, or really the most complex aspect of the part that I needed to get right. So bear with me here and just enjoy the thread milling, and then here in a second we'll jump over to the G14 threads. Alright, here we go with the G14 threads. I'm using a Datron thread mill, 20 inch per minute. Took me a little while to figure out what thread mill to buy for the G14 threads, because they do have that 55-degree angle. and the only place I could find was Daytron. It cost me a little over $100. If you guys know of a cheaper thread mill, let me know in the comments below. And here we see the 4th axis rotate to finish our G14 threads. I find it satisfying when the 4th axis rotates. I can't imagine what it would be like to have a 5th axis, but hopefully one day I will find out. And so that's it for our G14 threads. Now here in a few minutes, again, bear with me as we sort of watch the machining play out. Our final tool path will be a 2D contour where we leave tabs such that we can break our part off. Alright guys, this is the final tool path. Again, we're using the Gorilla Silverback 3/8 3-flute end mill, 30 inches per minute. Our depth of cut is 50 thousandths, and we are the entire diameter of the tool in terms of width of cut. Again, the goal here is just to remove the material on the back side and leave a set of tabs, 3 tabs in this case, that are 10 thousandths in thickness. That way we can break the part off. So that does it, guys. I hope you enjoyed the machining. Please leave any comments or suggestions below. Thanks again for tuning in. Please like and subscribe.